All right, perimeter and area, 1.6. Perimeter and area. Now, to understand perimeter area, we have to know the difference between the two, okay? Today, they're basically going to talk about rectangles or squares in perimeter and area. Okay, so let's look what perimeter is. All right, perimeter is the distance around an object. Okay, perimeter is the distance around an object. Okay, in this particular case today, we're talking about usually four-sided objects, rectangles or squares. Okay, some of the objects that we will look at will be rectangles and squares that they've put together to form another object. Okay, but the perimeter represents the distance around an object. Okay, so if I wanted to know the perimeter of this building, okay, if I wanted to know the perimeter of this building, I would get out here on the sidewalk and I'd walk along the outside walls until I made it around the building. Okay, and that would give me the perimeter. I would think that the perimeter of this building is somewhere in the neighborhood of, let's see, I remember when I did it a long time ago, when we were measuring to see what it'd take, how many laps to run around the building for a mile. Coach Coacher was trying to find a mile for PE, and I don't even remember. I need one of my little wheel measurement is broke, or we'd go out there and measure it and see what it is. But it's long, okay? It's big. Now, I do remember that roughly the square footage or the area of this building. The area of this building is around 74,000 square feet. Okay, that's a lot of feet. Okay. Now, area, when you figure the area of an object, the area of an object is what it takes to cover the object. Okay? For example, I'm going to change my paper here. Ooh, not that small. Let's go there. Yeah. All right. If you look at this, and let's say that we were going to draw I'm going to delete that one, do another one. Okay, I'm going to enlarge it over here. Oh. So basically what they're saying is this. How many of these squares does it take to cover that object? Okay. If I colored in all the squares, okay, how many of those it would take? Now, obviously here we can see that part of a square is here. So obviously they'd have to give me the measurement of like, let's say 1, 2, 3, 4. So they would say the distance is 4.7 inches. Okay? 4.7 inches and 3 inches. Okay? Now, to figure the perimeter and area of that figure, okay, the perimeter is the distance around this object. Okay? Well, to find the perimeter is equal to the sum of all the sides. What's the word sum mean? S-U-M. What does the word sum mean? Zach? Okay, an answer to an addition problem or an addition problem, either way you want to say it. But the sum means we're going to add. Okay? Now, the book is going to give you a definition for this, for perimeter. Excuse me. The book is going to give you perimeter of a rectangle is 2 times the length plus 2 times the width. Okay? That's what they're going to give you for a rectangle. I just always say the sum of all the sides. Okay? Because that formula only works for rectangles. Alright? So I just always say add up all the sides for perimeter. Because we're going to be dealing with 3-sided figures, 4-sided figures, 5-sided figures. You're going to be dealing with figures here in a second that may look like this. They may look like, okay, like that right there. Okay, so I just always say add up all the sides, sum of all the sides. Okay, understand that there are some little shortcut formulas if you got a rectangle or you have a square. One they're going to give you for a square is this. Let me change colors here. They're going to say perimeter is equal to 4 times S for a square. Okay, and S being a side of a square. So if I say I have a square that's 10 inches on each side, what would the perimeter be? 40 inches. Okay, because you take 4 times the side's 10 inches, so 4 times 10 would be 40. Okay, so to figure the perimeter of this figure, then we're going to do this. Perimeter is equal to 4.7 plus 3 plus 4.7 plus 3. Just like this school would have 4 sides because it's a rectangle, okay, somewhat of a rectangle. It's got a little indentation here or there, okay, but basically it's a rectangle. You're going to have this side over here, then the side by the field, and then the side by the tree area over there where all the little daycare kids and or elementary kids go out and run around and hang from trees. You know, some of you probably did that. Okay? Some of you may have done that since you've been here. Okay? So, if I take and add these together, so that would be 7.7 plus 4.7 plus 3. Perimeter would be equal to 12.4 plus 3. Perimeter would be equal to 15.4 inches. Okay? So what it would take is, if I was walking around that figure, now obviously it'd be difficult to walk around a 4.7-inch figure, all right, but the distance around that figure, when I went from here, start here at this point, I went up 3 boxes, then I went over 4.7 boxes, which made the 7.7. Then I went down 3 boxes, okay, and I put those next. I put 4.7 next. Didn't start with the 3, okay, but you've got the idea. And when you get to here, you would have walked 15.4 inches, okay. Now, for the area of this problem, the area of a rectangle is length times width. This is for a rectangle. And the area for a square is S squared. Okay, so this is for a square. And then this, I'll move it back over here by the A, is for a rectangle. Okay, the rectangle one works for either one. Okay, and I'll show you how that works here in just a second. But to figure the area of that square we drew, area would be, what is the length of that rectangle? Length is always the longest side, 4.7. So that would be 4.7 times the width, which is 3. Okay? And so that's going to give me the area is equal to 14.1 inches squared. The key here is this for area. Why is there a square above the label inches? What do you think, Selene? No. Good guess, but no, that's not why. Why do I have to put a square on my label? It has no mathematical value in the sense of I don't have to do anything to this problem. It's done. It's simplified. Okay? The square in the inches squared is a label at this point. It is not a mathematical, I've got to take and do this. Okay? Zach, what do you think? That's closer. That's closer to what I'm looking for. Sophia? Well, it's a square, but you would do it on a triangle as well. It would, if you were doing the area of a triangle, it would have to have it too. Now, here's why you have to do it. Okay? To figure the area, to find the area of any object, you have to take and multiply 2 of its dimensions. Okay? Any object. For example, a triangle. A triangle is 1/2 base times height. The dimensions there are base and height. Okay? If I take a if I take a trapezoid, okay? A trapezoid is equal to 1/2 the base number 1 plus the base number 2 times height. So the two dimensions are the two bases and the height. Okay? So to figure the area of this room, in other words, they had to put carpet in this room. Okay? Well, they didn't just come in and throw down a huge piece of carpet and say, oh, that looks about right, and just start cutting. Okay? They had to know if they had enough carpet for this room. Okay? What they did is they measured this wall all the way to there. They measured this wall all the way to there. And they got the area of the room. Okay? They didn't just go out to some carpet store for this building and go, that looks like enough. Let's have that. Okay? That pile over there. Let's get that pile. No, they went to this, they went to their supplier, not a store. They wouldn't go like to Home Depot. They didn't buy carpet from Home Depot for this place. They went to their supplier and said, hey, I need 74,000 square feet of this carpet. Okay? It didn't come on one row. Okay? If I had 74,000 square feet of carpet on one row, it wouldn't fit through the door down there. Okay? So, and obviously, you don't need 74,000 square feet. If the whole building is 74,000 square feet, well, do we have carpet in the cafeteria? That would be a nightmare. You can imagine what that would look like if we had carpet in the cafeteria. Poor Leo would be down on his hands and knees scrubbing every day, getting all the, the food, the applesauce, the whatever it is, all over the floor. So obviously in the cafeteria, we don't have carpet. In the gym, that's part of the square foot figurage. We don't have carpet. We're doing the other one over at the church. We played on that one in elementary for a while. But obviously we don't have carpet there. You don't have carpet in the locker rooms. You don't have carpet. There's a lot of places that don't have carpet. Okay? So they had to figure out how much carpet they have. So what they had to do is they had to measure the rooms. All the rooms are the same size. The art room doesn't have carpet, thank the Lord. Okay? Computer room doesn't have carpet. The science lab doesn't have carpet. So they have to measure all the rooms that had carpet. Then they had to measure all the hallways. And they said, okay, this is how much carpet we need. So they go to their supplier and they say, okay, here's what we need. Okay? And I haven't ever really seen it, I think in one room, I don't think there's any seams in my room in the carpet. Okay? There are seams in some of the rooms I've seen before. Okay? But they lay down this carpet. They had to do the same thing with the paint. You think they just went out and, I think 5 buckets will do? No. Paint covers a certain amount of coverage. In other words, if you look at a paint can, it'll say it covers 25 square feet. Well, what they're doing is they're measuring the height, or in here, the length of this wall this way and the width of this wall this way. And whatever that is, you figured up, that's how much you know. And everybody goes, well, I'll never use math. I guarantee you, before you die, you will paint a room in a house, whether it's your own or a friend's, or you will paint a room, and you will have to know how much paint it's going to take to paint that room. Now, some of you will go, well, I don't want to do math, so I'm just going to go buy 4 gallons. And then you'll have 3 gallons left over and pray that they take 3 of the gallons back. Okay? So this stuff of, well, you never use math. Baloney. You use it all the time. Think about these squares in the ceiling. That's area. Okay? Takes a certain amount of squares for each room. And you think about this. There's, let's see, we'll just do an estimate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are 2 foot wide and 2 foot this way. So basically that's about 24 feet this wall is. From that wall to that wall is basically about 24 feet. Okay, but we had 12 of them, and then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 going that way. So it's basically a 24 by 24 room. So if that means, think about this. That means there's 144 squares in this room. 12 by 12. 12 going this way, 12 going that way. The area would be 144. Okay? That's squares. So if there's 144 squares in each room, okay, that's a lot of squares. You think about, we've got 1, 2, we've got 2, 4, go over to the high school, 6, 8, 10, and then you won't figure the science room because it's a different size, and then you got that one Miss Shorter's in, so that's Mr. Clayton. His is a little bigger. His room's a little bigger. You have the teacher's workroom. So let's say you have 20 rooms that you got tiles in. There's more than that. You do the math on that. 20 times 144. What is that? 20 times 144. 2,000? 2,880? Okay. So 2,880 squares, tiles. And that's just the rooms. That's just a rough estimate. That doesn't include the hallways. All the hallways have those. Cafeteria has them. Okay? So you just think about that. So if you don't know math, and some of you in my group that were in our chapel service time, you said you want to be an architect. That's all part of architecture. Figuring all that stuff. Funny story is, when they first did the architecture plan on this building, you know where your water fountains are? Out here in the hallway? They originally made that a common sink, where you would come out of the girls' restroom and the boys' restroom, you wash your hands right there, and then you dry them off, and it was right there in the hallway. And I looked at that, and me and Miss Tidwell were talking one day, and I was like, Miss Tidwell, you realize that's like a sink, right? And she said, yeah, that's where the architect said they want to put it. And I said, has he ever designed a school? Yeah, he's designed a bunch of them. And I'm like, okay, let me show you what's going to happen. Sink's going to turn on, and Zach and Noah are going to be sitting there. I didn't use your names, obviously. Zach and Noah are going to be doing this. All the girls walking by. They're going to be taking that water, and at the time it was like Robbie Foster and, all those. I'm like, you really think they're not going to sit there and do this? When all those people are walking by, and we're going to have showers instead of sinks. Then we're going to find out, unfortunately the girls are going to find out how many boys don't wash their hands when they come out of the bathroom. Okay, and that's just another subject we're not going to touch. But, okay. You're going to find out who's clean and who's not. You're going to, who likes to keep germs off their hands. And she said, Coach, you're right. That's probably not a good idea. And so they redesigned it and put the sinks inside the bathrooms instead of the other way around. And so that's all part of architecture. It's all part of math. It's all part of, you've got to figure out how much this. It's all the same. But that goes back to why you have to have this. Okay? Area is two dimensions multiplied together. When you figure volume of something, for example, the volume of this. Now it's a lot more complicated. It's a lot more complicated formula for this because it's not a, it's a sphere. It's not, it's not like a square. But let me see here. Where's that? Okay, the volume of this speaker. Okay, you would take the length times the width times the height. So how many dimensions did I have? 3. So on volume, it would be like 114.1 inches cubed. Okay? Now, you talk about 4D. About several years ago, all the weathermen were coming out with these new 4D maps that you could see on TV. Look at this 4-dimensional map. Okay? Well, 4D is 4 dimensions. You have length, width, height, and what they added to it for the 4th dimension is motion. They added motion to the 3-dimensional objects. Okay? They added motion to the 3-dimensional objects. All right? And so that's another thing that they do. All right? So, when we're dealing with area, you must have inches squared, feet squared, meters squared, centimeters squared, whatever your label is, it must have the 2 at the top to say square. Okay? Any questions on that? Yes, Zach?
Is that only with area?
Only with area. With perimeter, you're not multiplying anything together. You're adding. Okay? And so with perimeter, it's just whatever label's there. Eventually we'll talk about volume. And so you'll have to do the cubed, okay? But right now we're just dealing with area. Hang on. I'm about to sneeze. Okay.
So that's only for rectangles and squares?
No, it will be for any object. That's a good question. For any object, whether it is a square, rectangle, hexagon, triangle, octagon, it must have the square if you're figuring the area. Okay? So for a triangle, the triangle area for a triangle is 1/2 times base times height. Okay? We'll learn about triangles later, but you would have to, at the end of your answer, if it was in inches, you would have to have inches squared. It's for any time you're figuring the area of any object, any type of object, you must have whatever the label is and the square above it. Feet squared, inches squared, centimeters squared, yards squared, all of that. Okay? Yes, sir. Area only. Okay? So, we've got perimeter, we got area. Now we're going to move to the harder one. All right, everybody turn in your books and look at number 25. 25. All right, 25, they give us a little different type of object, and I want to go over this. All right. It looks similar to theirs. We've got 5 feet, 1 foot, 2 foot, 3 foot. Okay? And they want to know the perimeter and area, correct? Is that what they asked for? Find the perimeter and the area? All right. So, for me, for the perimeter, I have 1, 2, 3, 4, 5, 6 sides. So I'm going to add up 6 things. Okay, the first one I'm going to start with is number 1 right there, and that's 3 feet. plus 5 feet plus 1 foot plus, now we got to figure out what 4 and 5 is. We have to understand, we have to find out what that is. And we also have to figure out what this is. Okay? So, how do I figure out what number 4 is, side number 4? What do you think it is? It's not hard. 3 feet. Why do you think 3 feet? Okay? If you look at this, if I make a rectangle that goes like that, okay, doesn't this side right here have to be 5 feet as well? Okay? Well, 2 feet of that is already right here. There's 2 feet, so this has to be 3 more feet. Okay, so we add 3 feet. All right, now, we got to have side 5. What's side 5? 2 feet. This is 2 feet. Because here's 1 foot, 2 foot has to equal the 3 foot. Okay? Now, the last one is 2 feet. So, you add all those up. 3, 5 is 8, 9, 12, 14, 16 feet. All right. Now, so we had 16 feet is the perimeter. Okay? Now, to figure the area, here's what you need to do. All right. We'll finish it up tomorrow. You don't have homework. Okay? We'll finish it up tomorrow and work on it in class.